Hello, everyone. My name is Sonia Winkleman. I'm the Director of Net Zero Energy Housing at the Canadian Homebuilders Association. Welcome to our webinar today. Before we get started, I did want to let everyone know that we are in listen-only mode, and I do ask that if you have any questions for our presenter, please use the questions section of the dashboard, and I will make sure to ask those questions of our presenter at the end of his presentation. So we will have at least 15 minutes for questions at the end. So as I mentioned, please feel free to pop those questions into the questions section of the dashboard. We are also recording this webinar, and we will also post the recording as well as the slide deck on our website at chba.ca/nzwebinars. So you'll be able to access that after the webinar is done. And before we have Jonas start his presentation, I'll just go over the overview of the webinar, what you'll be hearing from Jonas on today, as well as a little bit about our presenter. So today's webinar is called Energy Storage, a Home Builder's Introduction. Obviously, though, this webinar is not only for builders, it's for pretty much anyone who's interested in energy storage for homes. So the webinar basically is about energy storage being a natural step in the evolution of sustainable and resilient home building. So this cutting-edge technology increases the amount of solar energy used directly in the home. It also provides a reliable, quiet, and safe source of backup power. And for builders, it's a key differentiator that will change the way people look at your next development and your business as a whole. On this webinar, you'll receive an overview of the state-of-the-art technology, including how energy storage has been geared to residential applications and key considerations for including it in your current and future projects. This webinar combines an introduction to energy storage technology with basic guidelines on how to plan for and implement it. Key takeaways include energy storage solutions and configurations, criteria for selection, what you need to know in advance, and some builder case studies. Panasonic is the world's largest manufacturer of lithium-ion batteries with a legacy in energy storage that dates back to 1923. Panasonic Eco Solutions Canada is a leader in Canada's solar industry with over 55 megawatts AC of solar installed or underway. And about our presenter today, so Jonas Tekel is the manager of the consumer sales channel at Panasonic Eco Solutions Canada. And he's been involved in the clean tech industry here in Ontario for the past 9 years. He has extensive experience in business development for both direct-to-consumer as well as small commercial projects. He's involved in engineering, procurement, and construction of microfit, fit, and net metering projects, and also has previous experience in the solar thermal space. He's currently managing the consumer sales channel at Panasonic Eco Solutions Canada within their solar and energy storage solutions division. So without any further ado, Jonas, do you want to start off?
Okay, great. Thank you very much, Sonia, for that introduction, and good afternoon, everybody. Thank you for attending today's CHBA's webinar, Net Zero Energy Council's webinar, and I'll be focusing on residential energy storage solutions today. As Sonia mentioned, I'll be taking some questions at the end, but if there are any questions that we're not able to get to today, I'll have my contact details at the end of the webinar as well, so please feel free to get in touch with me directly as well. So thank you, everybody, and good afternoon. So I just want to talk about a little bit, just a brief overview in terms of some of the things I'll be covering today. So I'll give a brief overview of Panasonic, and specifically Panasonic Eco Solutions Canada, located in our head office here in Mississauga. We'll go through solar and energy storage solutions, some of the leading cutting-edge solutions that we offer currently. We'll talk more specifically about some of the system overview, including monitoring, configuration, and how that might relate to projects you'd be involved with. And then we'll talk more broadly about benefits of energy storage, what to look for, considerations before building your project, and then examples of systems that we've done as well, and then also installation warranty and case studies. So Panasonic Eco Solutions, I mentioned, is headquartered here in Mississauga, and we're Canada's leading solar industry integrator provider. We provide a turnkey solution, including all aspects of EPC, so that would be engineering, procurement, and construction services. We've done over 55 megawatts AC, 70 megawatts DC of installed capacity that we've either installed or that's underway. And we've focused on both commercial, residential, and community microgrid projects. So that would be net metering projects, FIT projects, as well as microfit projects on the residential side. We also provide competitive project financing. One of the things that makes us unique, I would say, is although we're a big brand, a global brand, we do have an in-house team of installers, designers, engineers, and electricians located locally. So that sort of gives builders a seamless experience in order to provide real value for their projects. So it's basically a one-stop solution where we do everything from project initiation to commissioning, monitoring, and service afterwards. So I do want to emphasize again that we're not just a distributor. Instead, we would help builders manage a process that's likely unfamiliar to them, and then ultimately one that helps them meet their clients' goals for clean energy systems. So Panasonic is the world's largest producer of lithium-ion batteries. Panasonic has been around for over 100 years now, and it's been about 80 years involved in lithium-ion technology specifically. So that would provide, your clients with a high level of trust and confidence that we know what we're doing, first of all, and then we're going to be around to, provide them with information, service any systems that might requirements, and honor warranties. Also, in the next decade, there was a study by IHS Markit done in 2016 where they've determined that in the next decade, lithium-ion, the technology specifically, will be very mainstream, and 80% of the global energy storage solutions will include that technology by 2025. And we've really committed to this, and why we've are developing ourselves and worked with solar energy providers across the country. So there's three main types of systems that we're looking at when we're considering solar energy storage solutions. So the first one is a solar and storage ready solution. So this is maybe a homeowner or builder wants to future-proof the home, is considering in the future, but perhaps they're just not ready to install it right now. So there's a lot of things that we can do on the design and engineering side. More practically, we can rough in a lot of the components, the wiring. We can also do design consulting in terms of, what the roof should look like, if there's any flexibility there, or if it's early stage in designing the home. So we can advise you in terms of the azimuth, the spacing, what's required to get that ready down the road. Secondly is solar and storage. So this is incorporating a traditional solar PV system, which I'm sure a lot of you guys are familiar with through microfit, FIT, or even net metering systems that you might have come across. But then that's, the next wave right now is incorporating those systems towards net metering. So as opposed to using that electricity from the PV to sell it to the grid, you're using it yourself for your own consumption to lower your hydro bills and doing other things. And then coupling that with a storage solution, so essentially a battery solution. Now the third one is storage only. So there are solutions that we offer as well, where perhaps solar PV modules on the roof isn't feasible for whatever reason, but the client wants backup power, or they want to do things such as low shifting, charging the battery when rates are low, and perhaps using that battery power when rates are more expensive. So a storage only solution, a battery only solution would help them with that. I'd like to mention we are brand agnostic. So we really take the approach where we want to look at our clients or builders' needs, their objectives, what they're trying to, what their clients are trying to meet, and really design a solution and configure a system that meets those requirements. So we have a lot of flexibility in that. We have a lot of experience doing that. And then also with the different solutions we provide, there's a lot of flexibility in the configuration, and also the fact that some of our systems are stackable, so adding multiple batteries to the same system. I think for most builders, especially ones that are trying to meet net zero requirements, it's probably the middle option that they're going to be interested in the most, which is a solar coupled with energy battery storage system. So this slide here just gives you a general idea in terms of how the system looks and how that power is being produced and how that flows throughout the home. So we'll start at the top. So you'll see we've got solar modules on the roof. Again, we can provide some on the front end, some advice in terms of how to best position it, what size system would be feasible. And very important actually is for homeowners to or the builders to do an energy audit to determine what are their loads going to be, what kind of access to power do they want to have available if the grid goes down, if there's an outage, what sort of loads that they want to power, and what are their bills and how much savings they could potentially gain. So we've got the solar PV modules at the top. That DC power then flows. This is our Tabuchi unit that we've got there at the bottom floor of that house. So that's the Tabuchi inverter that's mounted on the wall. So that's DC going from the modules to the inverter, and then that DC power then flows to a 10 kilowatt battery that we've got situated on the floor there. That power can also, the inverter also converts that power from DC to AC, and that power goes to the main panel of the house, straight to television, fridge, appliances. And it can also, when there's a power outage, go to a pony panel, a sub panel, so that the homeowner has backup power during times that there's an outage as well. And it's a smart system, so it knows when the grid's no longer there and there's a problem, and then it diverts that power to the backup panel. Also, when there's not an outage, when the grid is there, that power that's not being used in the home then goes to the bidirectional meter, which you have there on the left-hand side. So that power that's being generated by the solar panels, or even from the battery, then goes back to the grid in a net metering scenario so that they can have some savings. So just like to speak in terms of the main components of the system, what we're looking at is a solar PV on the roof. The racking that would mount the solar panels to the roof, and we can work with metal roofs, standing seam, regular shingles, etc. We've got, oftentimes we'll use optimizers, which in some cases can manage a panel individually, so you've got panel level monitoring, or in one of the examples for our solutions, which I'll talk to later, we have PV links, so that can help with shading concerns and give you a lot more flexibility when designing the solar PV system. The heart of the system is really that inverter that's mounted on the wall, and then the battery unit, which is usually situated beside it. Our systems come with a monitoring unit, so you can, in some cases, change the modes of how the system operates, and it allows you to get valuable information in real time, and also historical data in terms of your production and consumption numbers as well. We've got the bidirectional meter as well, and then, as I mentioned earlier, the sub panel. So, as many of you know, solar itself has really sort of come down pretty drastically in the past few years for a number of reasons, and that would be true not just here in Canada but globally. And really, the next stage is really energy storage and coupling that with solar, and you get a lot more benefits by doing that. So some of the benefits that you'll see, the value of solar and as well as coupling it with storage, is increasing the amount of solar that you can use in your home and how much you can offset, as opposed to just selling that electricity within, you know, a microfit or fit application. You get a lot of security in terms of being able to have backup power when the grid goes down, and this is becoming more and more of a priority. So in terms of capability, you know, you might not necessarily have the same type of capability you would with a traditional generator, but it's quite meaningful in terms of, you know, you're able to keep your essential loads running, keep the lights on, you know, in some cases keep your house warm, keep the fridge running, and as opposed to traditional generators, you know, it's clean power, it's quiet. You're not paying continuously for fuel such as gas or diesel. So it's also quite quiet, and you're able to recharge it. It also provides you peace of mind. So, you know, it helps you protect your investment, your home, which is in many cases your largest investment. So in such ways as preventing the pipes from bursting, giving you access to being able to charge your cell phone when the grid is down in times of emergency. I'd also like to mention that currently, under net metering, we're in a tiered pricing sort of setup, and all of our solutions can definitely run in that sort of setup. But the incentives, as many of you know, is sort of transitioning from a microfit sort of world towards net metering, and those are actively being sort of finalized. So I think in the not too distant future, we're definitely going to be able to take advantage of time of use scenarios, peak shaving, load shifting, all that sort of stuff, and all the solutions that we provide can definitely do that. So this is one of our sort of flagship main solutions. It's Tobuchi Electric's solar plus storage all-in-one solution. It's a 6 kilowatt, well actually it's able to integrate a 6 to about a 7 kilowatt solar PV rooftop system. It's a 5.5 kilowatt hybrid inverter. It comes with a 10 kilowatt lithium ion battery unit, which is in that image there, and 6 kilowatt hour battery capacity is usable. It's 2 kilowatt power output, so discharge, and 3 MPPTs. So MPPTs is basically how it regulates the solar PV unit. So in some ways, almost, you know, you can take that 6 to 7 kilowatt solar array, and you know, the 3 parts of the system almost work independently. So if it's a pretty fragmented roof, if there's perhaps shading issues on one part of the roof, those 3 MPPTs help to deal with that. It's very efficient, you know, industry leading in terms of efficiency, 95.5% peak solar efficiency. There's 3 operational modes, which I'll go into a little bit later. It has a remote controller that can be mounted on the wall, in the basement, or you know, in the kitchen, wherever is convenient. And the monitoring allows you to monitor not just the battery, but also the power coming from the solar PV, as well as the home's energy consumption. And I'll go through that in a little bit more detail. Tobuchi Electric is a leading worldwide solar inverter manufacturer. They were founded originally in 1925 in Japan. And they developed and manufacture state-of-the-art solar inverters for about the last 20 years now. And Panasonic has a very close relationship with them in terms of it's our lithium-ion batteries in their units, and we have a very strong relationship in terms of installation, service, and support. You know, I do want to emphasize that, again, the approach that we take is looking at the needs of the system and then designing a solution, the size of the system, the configuration, the components we use based on our clients' needs to optimize their savings. But typically speaking, in terms of price, this is, you know, this system here, including the solar PV, the racking, application, pretty much everything from beginning to end, commissioning, monitoring, we're probably looking at around a 35 to 45 kilowatt, sorry, $35,000 to $45,000 range. And again, that's going to really depend on the particular roof, the size, and configuration. This gives you a little bit more detail in terms of how the power flows throughout the system and how the different components are connected. I sort of covered this in the other diagram in a little bit more detail. But one thing is, from the AC to the DC side, there's about a 1.25 ratio. So what that means is it's actually good design to oversize the solar PV system. So if you've got a 5.5 kilowatt inverter like the Tabuchi here, you can get anywhere close to 6 to 7 PV kilowatts on the roof, and that's really good. That actually allows the inverter to wake up earlier in the morning during lower light conditions and stay on later in the day. It's part of good design and well within the parameters, the working parameters of the inverter. I mentioned earlier that there is 6 kilowatts usable capacity, and that comes with a 10-year warranty. I'd also like to mention that there is an option for the same inverter with a 7.5 kilowatt usable battery that comes with an 8-year warranty. So next I'd like to talk about Tabuchi, the different operational modes that come with the system. These are very easily can be changed through the controller that would be, generally speaking, located in the basement beside the units. So there's 3 main modes that it comes with. So the first mode is called max power. So all these modes, whether you're exporting to the grid using solar in the home or ensuring that the battery is fully charged, you can do this all from the monitoring system. So the first one, max power, is where the battery is charged from the grid during that night. So this is a situation where you have the most amount of savings in the net metering scenario. So the power during the day when you're generating PV power from the sun, the power is then sold to the grid as part of net metering. During peak times, when electricity prices are the highest, the battery use reduces, and during demand charge at night, the battery is charged by the grid. So essentially, this allows you to take advantage of the power that the modules are producing, that free electricity that they're producing from the sun, and then able to charge and discharge the battery when the rates are cheapest and then when they're also more expensive. So the next mode we have with the Tabuchi system is the economy mode. So this scenario, the battery is charged by PV and excess power is sold to the grid. So daytime, the PV charges the battery, and then at night, the power is supplied to the battery. So you're not necessarily, compared to the first example, max power, selling as much to the grid, depending on your consumption, what your loads are during the day and at night. But you're able to sell that power as well as charge the battery during the day from the PV that's generated, and then purchase electricity in the evening and top up, and get that power from the grid. So the last mode here is backup. So this is really where you're telling the battery, listen, I need you to stay fully charged at all times. You can actually change what percentage, so you can have it pretty much at 100% fully charged. There are, you do have the option if you want a little bit less than that, perhaps 90%, 80% as well. So that's really the main incentive here, what the battery is being told to do. Once the battery is fully charged, it's only used in the case that there's a grid outage. So you're not discharging and charging like you are with the other 2 modes. This is really interesting because there might be an example where there's a storm coming, and perhaps you expect that there might be an outage, you can go from one of the other modes, max power and economy, and then change this mode to top up that battery. So if you expect a storm is coming, in the next day or so, your battery is fully charged, and then for the duration of that time, you can use that power for the battery. During the outage, the solar PV can then charge the battery. And it's very important to size these systems properly. So we need to look at, what kind of loads do you have? How long do you want that power for? But if we size it correctly, then the PV can almost continuously recharge that battery that's in backup mode. One of the great things I would say in terms of the Tabuchi system is really their monitoring, and not only how easy it is to use, but just the interface and the information it gives you. So this is an example of what it actually looks like. So it's very easy to get used to. It's a web-based monitoring system. You do have the physical console that you can change the modes from, but you can go online and even remotely and check what's happening with your system. So the monitoring allows you to do a few things. So you're able to monitor the energy production of the solar panels, so how much electricity you're producing. You're able to see how much you're buying from the grid in real time. And although this is not the actual, I haven't logged in here, this is just a screenshot, but you can kind of see how those lines would flow back and forth. You're also able to monitor how much power your home is consuming, and then also what state of charge the battery is in. So in this example, you can see that it's 100%. There's power flowing 5.55 kilowatts from the solar PV array, how much power you use today, and then also how much your home is using. And in this scenario right now, there's no power that's being bought from the grid. The monitoring data is provided in real time and historically. And the next slide here is performance tracking interface within the same monitoring system. So this gives you the information during the timeline of a day, and you can see where all your consumption and your production is coming from. It provides you also valuable information, so you can make adjustments to your energy usage, and you can change perhaps some of your behavior to optimize your savings and to also reduce your environmental impact. So I'd like to briefly touch on also another one of our solar plus storage solutions that we provide. So this one is by Pika Energy, which is a company out of the States that Panasonic has begun sort of working with in the last year or so. And we've got a strong relationship with them. So this is a 7.6 kilowatt DC coupled smart inverter. It can provide either 10 kilowatts, kilowatt hours, or 15 kilowatt hour lithium ion battery. Again, that's a Panasonic batteries that are in this unit. And it's very efficient, so 98% peak efficiency. This system uses PV links, so these are similar to optimizers, which some of you might be familiar with. Up to 4 PV links, each one is 2,500 watts, so 2.5 kilowatts. Optimizers, again, this also gives you, and you can see that component sort of at the top right-hand corner above the inverter beside the battery there. So again, this gives you a lot of flexibility when designing the PV system. Again, if the building is, if there's obstructions, if it's fragmented, if there's shading. There's 4 breakers in total, so one of those breakers would be dedicated to the PV system, and you can connect other breakers as well, so you can incorporate other types of battery solutions. You can potentially do even down the road HVAC units. So really what makes the system really unique that is it's sort of a nano grid. So for example, you might have somebody that's really not ready to go and incorporate battery right now. However, they can do net metering with that inverter and incorporate the battery unit later. They can incorporate other sort of storage technologies as well. And as we're progressing towards net metering and those incentives get ironed out in the next little while, this system really gives you the flexibility to take advantage of anything that comes down the line. So whether that's time of use pricing, whether that's virtual net metering, all sorts of stuff. And this is just a sort of a very sort of rudimentary configuration of what that looks like. So of course you have the solar modules that goes into the battery unit. They have their system rebus with the 4 breakers, and then into the inverter, and then that'll go through your main panel, your sub panel, into the loads of the home. So there are a few considerations as builders, installers that we all need to take into account when we're speaking with clients. So I've sort of listed out some of the main ones here. So the roof. So we want to look at obviously the condition of the roof. We obviously want the roof to be in good condition. In many cases for the builder, it's going to be a new roof, so that's that's not an issue. The azimuth, so whether you're building it or it's a retrofit, we want to look at the production, the available roof space, where it's tilted. There is a lot of flexibility, which a lot of people are surprised. So you don't need to have a perfect south-facing 30-degree roof, but if we can help it on on the front end, we can definitely provide you with information on how to best design that. There's also things in terms of roughing that we can do on the front end. So that would be, as simple as things as running conduit for a new build through the home, so you don't have any wires on the exterior, providing adequate space not only on the roof but in the basement for the battery and inverters. And then providing sort of consultative consulting advice as well, which we can do. What's actually quite important too, is, as many of you I'm sure know, is design aesthetic preferences, especially of the PV unit. PV, obviously, beauty is in the eye of the beholder, so I'm a little bit biased myself, but aesthetic is very important. Solar modules aren't necessarily those blue crystallized, not very aesthetically pleasing modules that a lot of you may be familiar with. The modules nowadays, even the polycrystalline blue ones, are quite aesthetically pleasing. And then we also offer black on black modules. This is a black monocrystalline module with a black frame and black backing, which is very aesthetically pleasing. And also it's the way you design the system. So we need to understand what is the client's preference. Maybe they don't want modules on the front of the house, on one side of it. Are there obstructions that we have to deal with? So those are all things that we want to look at very early on in the project. And then very important, obviously, for storage and solar systems is load requirements. So energy audits are very helpful for us in determining what size system we should be looking at, what configuration, which of these solutions that I've previously discussed and other ones that we have available might be most suitable. Number of expected outages, the duration of those outages. So it's a really holistic approach that we want to take to designing these systems. The approach is to gather all this information and then design a solution that your clients are really going to be happy with, that's really going to give them savings and meet their objectives, not the other way around, trying to present them with the solution and hope it meets what they're looking for. So in this slide, I'd just like to give you just a snapshot. As you all know, things are changing in the energy sector with the utilities, with renewable technology. in real time, it's really promising, and I think I'm quite optimistic myself in terms of where it's going, and I think it's going in the right direction. But this is just to give you a snapshot in terms of some analysis in terms of utility rates and what they've done previously and perhaps where they're going. And this is really good, and I think it's a partnership between, a lot of the utilities are very progressive, a lot of builders are very progressive. So there's a real opportunity there to work with all partners and really take advantage of the infrastructure that we have, that we're very lucky to have here, as well as the technologies that are improving. Solar has improved, and the price has gone down extensively over the past years, and I think storage battery, lithium ion is really on the cusp of doing that. So we can really sort of take advantage of these technologies to help clients reduce their bills. This is just to give you an example in terms of what you're offsetting more from an environmental aspect. So the equivalent of trees planted, 3,000, how much driving, and then tons of CO2 emissions. This is really, this is assuming a very, a typical roof, or a good roof for solar anyway, with a good azimuth, good tilt, located in Southern Ontario using tiered pricing assumptions. And it's, a 6.85 kilowatt system, which would be very typical for the two systems that I overviewed, especially the first one with Tabuchi. In terms of industry standard, we provide an installation labor warranty, workmanship warranty of 3 years. The batteries and inverter typically come for our storage and solar units of 10 years. Some of our units, you can extend the warranty, so if somebody's interested in that, we can definitely have that discussion, give you pricing for that. The racking solution, we use all types of racking, aluminum racking for shingles. S5 clips can be used for standing seam roofs, for example, and they come with a 20-year warranty. And the solar modules, they come with a 10-year workmanship warranty and a 25-year performance warranty. They're often backed by a third-party insurer. And obviously, hopefully Panasonic is not going anywhere, so we're very confident we'll be around. And it'll be a one-stop place for you to come if you have any service issues, if you have any monitoring issues that you want us to look at, if there's any changes to the system that you'd like. You don't have to go around chasing different manufacturers. So, and part of that is because we do provide a turnkey solution and we do everything in-house. So we'll do everything for you from the engineering, procurement, construction, and servicing after the fact, and also be your partner in terms of marketing as well. So I'd just like to very briefly, I don't think we have a ton of time left, so very briefly just talk about a couple of examples of projects that Panasonic has been involved with, and Panasonic Eco Solutions here in Ontario. So this first one here is Fujisawa, Japan, which is a smart community there that was opened up in 2014, a very sort of cutting edge, ambitious project. And Panasonic was the lead developer for this. So this smart community involved 600 detached homes and 400 apartments. Each detached home incorporates Panasonic branded solar modules, a Panasonic battery unit, as well as Panasonic Eco heat pump and hot water system. And each home will produce on average about 4 kilowatts of solar energy. Once it's completed, they're going to see about a 70% reduction in CO2 emissions, 30% reduction in water consumption, and 30% renewable energy use, and about 3 days of off-grid capacity capability for this community. This next example is a little bit more local. So this is not Japan. This is in Guelph, Ontario. So this is Timberworks. So this is currently in development, and I think they've, excuse me, broken ground, and will be actually scheduled to do the PV and solar storage installation soon. So this is a luxury home developed by Timberworks for development with other luxury homes. This is the first one that we've developed in the hopes of developing the other ones. This is a 9,000 square foot home that's aimed to be net zero. It's a luxury home, as I said. So because it's a luxury home and it's a large home, there is substantial energy consumption, but we're able to incorporate a larger 25 kilowatt solar array, and that's coupled with a 27 kilowatt hour of energy storage, battery storage. Therefore, the homeowner will be able to achieve net zero. This is obviously much larger than your typical home, but it gives you an example of being able to customize it, looking at what their needs are, and still be able to design solutions that match those needs. This is another example of a system that we're developing for Royal Park Homes. This is for their Simcoe Shores development located in Barrie, Ontario. And their base package incorporates our Tabuchi solar plus energy storage solutions. And they've incorporated that for all 8 of the detached home units for this development. Each unit is about 4,000 square feet on average. And these are net zero homes, and they've branded these homes as Powerhouse. They're about to break ground, and Panasonic Eco Solutions has completed all the design and engineering so far, and we're looking forward to the actual installation soon. So yeah, that's my presentation. So thank you for your time, and I think now we're going to be opening up to, I hope we have time for a couple of questions.
We definitely do. Thanks so much, Jonas. I'll start from the top. So we've got Michael here is asking whether or not your battery solutions will work with AC. So can they feed AC into your battery, because they already have an inverter?
So the battery, so just the battery itself?
I'm assuming based on the question. Yeah, so I'm thinking if they already have the inverter.
Yeah, so we'd have to look at that and see what the specifications of the inverter is. One of the challenges with a lot of inverters in the industry, and some of the pros with some of the solutions that I highlighted, is that you can't retrofit them. So if it's an inverter that's been designed for PV or for a particular size system, you're not able to necessarily be able to incorporate storage into that. So again, we'd have to look at the configuration of the system, the specs of the inverter, and see if that's a possibility. But that's really related to the capability of the inverter, the existing inverter, and not necessarily the battery itself.
Gotcha. Okay.
Yeah. So and I'll just mention, Sonia. So the Tabuchi unit is all in one unit, and that's actually one of the main advantages of it, that it's all integrated, all in one. You've got the same manufacturer, Tabuchi, that develops both the inverter and the battery, so it's seamless. And then you've got our lithium-ion batteries developed into that. So that's really one of the main advantages. And then you've got the Pika, which so if they had a Pika inverter, for example, and they incorporated PV with that now, then definitely down the road you could then install battery. And as I mentioned in my presentation, that's what's great about it. So you can sort of start now with just the inverter, and then sort of add to that later as their needs change.
Great. Thanks. And Jonathan has a question about your experience with having with using EV as the backup storage. So I'm assuming he's meaning instead of having the, say, Tabuchi battery, you'd have the EV battery as the backup storage system in conjunction with the net metering system.
Yeah, that's a great question. So you can do that, and again, that's what's great about the Pica system, for example. So it would allow you to do that. So there's, I think, 4 breakers in total. So if you're going to do it with PV initially, you would dedicate one of those breakers for that. But it does actually give you the capability to incorporate other technologies later. So EV would be one of them. You can actually even incorporate a generator if you wanted to. You know, lithium ion, I mean, you know, I really feel that's the strongest sort of type of technology right now for many reasons. But you could do a lead acid. So again, depending on the type of solution you have, what your requirements are, what your existing system is, or what your future needs might be, you would, you know, potentially have the capability to do that.
Great. And Jonathan is asking if you have an off-grid solution.
Our solutions right now are grid-tied. We are working on an off-grid solution, but both of the solutions that I highlighted, so both the Tabuchi system, which is an integrated solution, is a grid-tied solution, as well as the Pica. Now again, it's, you know, they are making changes to it, and you know, a lot of those changes are actually more on the software side of things. So we actually expect that to be available in the not too distant future. There are different sort of things that we could potentially source. So I would say right now, that's not the case. If they are interested in an off-grid solution, depending on whether they're trying to do PV and storage or only PV or whatnot, what I would recommend is they can get a hold of me. So he can get a hold of me and we can talk more specifically what that is. Again, if it's energy and storage, that should be coming, you know, down the pipeline relatively soon.
Great, thank you. And Jonathan's wondering if you could explain what 3MPPT means.
Yeah, good question. So I won't get too technical, but MPPT is essentially, what it does is it essentially divides the PV array into 3 sections. So traditionally speaking, you have, let's say you have, you know, 30 modules on your roof. So if you have a tree there and it's blocking, a lot of you guys know this already, but if you have a tree there and it's blocking half of that roof or a third of that roof, it could affect the production of the rest of the system. What MPPT does, it's called Maximum Power Point Tracker. So it kind of isolates each section of the roof. When we do the design and the engineering of the system in the front end, the way we string it and the way we tie the solar panels to each MPPT is pretty important. So if you've got a tree, for example, you can isolate that one. So if the tree only shades the roof for a third of the day, then it's not, you know, while it's been shaded, it can sort of lessen the effect of the rest of the system. If you've got a chimney and it's shading part of the roof, you can do that. The other thing too is oftentimes in the majority of systems, we're using multiple aspects of the roof, right? So you don't always have to have a perfect south-facing roof. An east-facing roof works quite well. A west-facing roof works quite well. A very, you know, a quite pitched roof is fine. A low slope is fine. If it's a north pitched roof and somebody's telling you to install on that side, where we're located, you probably want to walk away from that. You really don't want to use that. But if you're using multiple parts of the roof, then the MPPT you can dedicate, for example, the south-facing roof, the large south-facing roof on 2 MPPTs, and then perhaps the west-facing roof on another MPPT. Because what's going to happen is, as the sun goes across the sky, it's going to hit those different parts of the roof at separate times, and therefore the voltage and everything is going to be different. So therefore, you don't want to regulate them all the same. So although you have the same inverter and that power is all going to the same inverter, the MPPTs allow you to isolate them and optimize it. So the Tabuchi unit, the first one I went through, really optimizes the 3 separate MPPTs. With the Pica, it's more of a PV link, so the technology is a little bit different, but it does the same thing. So anyways, it helps, it gives you a lot more flexibility with design, and essentially gives you ideally better production.
Great, thank you so much for that explanation. Dominic is wondering if you could tell us the price of the battery storage only without the PV and the inverter.
It really depends on, so I mean, you're probably, you know, I'm kind of hesitant to do that because, and I know people want that pricing, I'll give a general price. So, you know, I would put it at around, you know, let's say 20, 25K. But I'm quite hesitant to do that because if you are looking for specific pricing, you know, as I mentioned earlier, our approach is really to look at all the different aspects. There's a lot of things that we need to consider, the size of the system, the configuration, all that sort of stuff, and as well as the objectives. So we first want to have a discussion, okay, what are you trying to achieve? Because a lot of people think, okay, I want one thing, but based on their objectives, a different type of solution would be perhaps more suitable. So we really want to have that conversation first and then give you the configuration and pricing of the system. Again, generally speaking, as I mentioned earlier, if you're looking for both PV and storage, then you're looking at, you know, roughly, you know, anywhere 35 to 45,000. And again, I know that's a pretty broad range. It can be a lot more than that. It can be a little bit less than that. And that's just depending on all the reasons I just highlighted.
Okay, great, thank you. Dominic was also wondering whether or not the battery storage and inverter could be placed outside, thinking just to reduce taking up space within the house.
Yeah, good question. So the battery and inverter, you know, I'd have to, traditionally speaking, inverters can be placed outside. And, you know, a lot of the inverters that we use, so whether it's just a PV system or incorporating storage, they're really built to be quite robust in commercial applications. So generally speaking, they can be located outside. With the battery, I think typically we want the battery indoors. I think we do have solutions perhaps where they can be located outside. I can definitely double check and follow up with him. But typically speaking, we'd like to have it indoors.
Yeah, my thinking is I have an EV and I can definitely tell the battery on my EV, it definitely reduces when it's cold. So I'm thinking if you are going to have a outdoor battery storage, you'd certainly need to make sure it was kept warm.
You're absolutely right, and that's a good point, Sonia. So with our units, there's certain criteria in terms of temperature. I mean, the ranges are quite quite large. I'm trying to just pull it up here in real time, but there is a lot of flexibility, and obviously we're in a climate where it can get really hot and really cold, but the range is quite extensive. I mean, the irony here is sometimes like the batteries don't like the cold, but a lot of the other components like the wiring, the PV, even the inverter does like the cold and it operates better in the cold. But there's definitely a very large range there that can work effectively. Okay. The other thing I just want to mention is that we understand that clients, homeowners, builders have a lot of preferences. So we do have a lot of clients that, you know, maybe they don't want it in the basement, maybe they want it outside, maybe they want to have the components located in the garage. So there is a lot of flexibility in that regard. And these are all discussions that we want to have as soon as possible, especially if it's a new build.
Right. What's the typical payback period for a standard installation construction, just in an optimal configuration? Richard's wanting to know.
Yeah, so I assume he's talking within a net metering scenario, so where you're selling the electricity where you're actually using that electricity yourself for your own consumption. So again, this is going to vary so much based on the roof and the system and your usage and all that sort of stuff. But typically speaking, I mean, we can look at anywhere from, let's give a range of like 8, maybe 9 years to 12 years in a net metering scenario. I don't consider the battery within that calculation because when you're looking at batteries, you're not really considering payback. The same way when you're considering a generator, you're not saying, okay, what's the payback period of this generator? You're more thinking of, hey, this generator is providing me power when I need it. It's providing me security, all those reasons. So when we have that discussion about payback, we're really looking at the PV array within a net metering scenario.
Wonderful. And someone is asking what the cooling requirements of the inverter are. So I don't know. I'm sure there's probably specs that come with the inverter, but do you have some ideas on that?
In terms of the temperature, you mean?
I'm assuming, yeah.
Yeah, you know what? I'm actually looking at the data sheet right now. I don't have that at the top of my head, and the font is quite small. But I can probably follow up and provide that to everybody pretty easily.
Okay.
I know the range is I mean, really it's there's an internal fan. The ranges that they make for these things are really, really high. So yeah, so it'll be in most cases an operating range.
Great.
Yeah, sorry. So I'm just looking at it here. So I just found this. So it's from 0 to negative 40 degrees. Sorry, from 0 to 40 degrees Celsius.
Okay.
Yeah. And you know what? We can actually share the spec sheet with everyone. So we can perhaps post that, Sonia, or share that with everybody if they
Okay.
like.
Maybe you can even put it at the end of your presentation so it's at the end of the slide deck when we post it.
Sounds good.
Great. Okay, so we have a few more questions and only a few more minutes. We actually have Sean from Timberworks on the call here. So one of the case studies that you put up on the slide. He's wondering, can you
Awesome.
update us on the Tesla solar shingle and when can we expect it in Canada? Do you know about that?
Unfortunately, well, good to have you there, Sean. I haven't worked with you directly, but I know you've worked with. I assume you've worked with some of my colleagues, so it's good to have you on the webinar. In terms of the solar shingles, so there's obviously a lot of publicity around that right now. I'm not sure if it's actually available. I don't believe it is. And, these are solutions that we're very excited about and looking forward to. But unfortunately, at this time, I don't think they've given us any sort of timelines or even pricing at all. As a lot of you guys know, Tesla is really good. I mean, they do great stuff, and they're really good at marketing their stuff, but sometimes a little bit slow on the pricing and availability, but I'm sure that'll come.
Great. Jode also wants to know, does the system offer any option for thermal, mass, or water storage integration, or is the heat pump add-on the only option for home heating, so assuming direct electrical heating is too expensive?
Yeah, generally too expensive. We don't really have the heat pump solution. I've worked in PV and solar thermal for quite some time, but I'm not really that familiar with that technology per se. The little that I know about it is that, and some might argue with this, but it's not as efficient to make it feasible in most applications. But unfortunately, I can't give you too much information regarding that.
Okay, great. Well, let's. I think that's something, Jode, that maybe we can have an offline conversation on as well.
Sure.
Okay.
Sounds good.
And we have 3 more quick questions. I'm just going to run through them here. In the max power mode, the assumption is the net meter is on time of use. Is this the case currently in Ontario? So that was one of the things I wanted to bring up. We've got obviously an audience from across Canada here. So
yeah.
Really the only time of use instance is in Ontario right now, as I don't believe any of the other, at least not that I'm aware of, that any of the other provinces have time of use.
Yeah, so that's a great question, and I tried to sort of mention that during the webinar, and I'm glad that it's come up again. So right now, in those modes, because when you go on net metering, you automatically get moved to tier pricing right now. I wanted to really highlight the capability in different modes of the system, but you would be moving to tiered pricing here in Ontario. That might be different in some other locations in the country. However, that being said, as many of you know, this is the last year of microfit on the residential side. So that's selling the electricity back to the grid, to the utility. And it's really going towards net metering, which is very exciting and which is what a lot of more mature solar markets have already done or that are going towards. So all that being said, we do expect very soon you'll be able to take advantage of time of use when doing a net metering PV system, when incorporating solar PV and storage. So you'll have the capability to do peak shaving, to shift your loads, and do all that sort of stuff. So as far as I know, those are in the talks right now. And hopefully not only will you be able to do that, but potentially communities will have the capability to perhaps even do things as interesting as like virtual net metering and that sort of stuff.
Right.
So it is, yep.
Sorry, I was just going to say, I'm assuming that the utilities will certainly want to push people towards self-consumption during the peak periods, correct?
Exactly, and that's really interesting because I think a lot of the utilities now, there's quite a few of them that are quite progressive. We've actually done a pilot project in Oshawa with the utility there, with 30 homes with a Tabuchi unit. So they're doing a lot of really cool things in terms of wanting to manage these systems on a community level, being able for themselves to be able to have power when it's at peak. So it's sort of it can be a mutually beneficial scenario, and I'm hopeful that that's sort of where we're going in Ontario, and I think that's where we're gonna be headed. And that's definitely where the technology is going as well. So, Panasonic Eco Solutions, we're sort of, on the threshold of that to be able to take advantage of not just the technologies, but also when these new incentives come into place.
Great. I'm just going to try and squeeze in one last question, and we're going to have a couple there left over that we'll have to address offline. But Michael was asking, how much per kilowatt hour will storage save on the electricity bill? And I'm assuming that's going to certainly depend on consumption, no? And generation, but
yeah, it's really hard for me to give specifics, and again, that's because as we all know, everybody's usage is different. Everybody, anybody that's doing battery, you might want to size the system differently. Certainly, the PV array will be different. The time that you use the power is different. So I can't really give you specifics from a kilowatt hour standpoint. In terms of a percentage standpoint, you could offset. I mean, in some scenarios, up to 100% or close to it. If we're talking more typically, your average installation, your average home, well, then maybe we're looking at anywhere from 50-60% to 80%.
Great. All right, well, that's all we have time for today. Thank you so much for your presentation, Jonas. And for everyone who would be looking for his recording and slide deck, again, that URL where you can find that would be www.chba.ca/NZ-webinars with an S plural. Or, of course, you can always reach out to me and I can point you in the right direction on our website as well. So thanks again, Jonas, for your time.
Yes, thank you very much, Sonia, for organizing it, and thanks to everybody for attending.
Great. Well, have a wonderful afternoon, everyone.
Take care. Thank you.
Thanks.